So the next section we come on to is the idea of the mole, and the mole a lot of times causes a wee bit of concern and confusion. There's not actually too much you have to understand about the mole. All it is, it's a word that represents a number, and again, there's many examples of that in everyday life. A really common one would be a dozen. A dozen, always means the number 12. The mole kind of just fits into that system. It is just a word that represents a number. Now, a number is a little bit strange looking. It's 6 times 10 to 23, so obviously it's a very big number. You obviously wonder, why is it that very strange number? Scientists came up with this number just because it has a handy relationship. It allows you to very easily work out going between a mass in grams and a number of atoms. What I mean by that is, they worked out, if you take an element like carbon, which has a mass number of 12, and then you weigh out in grams, just using pair of scales, that mass number in grams. So in other words, if its mass number is 12, I'm going to weigh out 12 grams. They worked out it always has, if you do that kind of relationship, 6 times 10 to the 23 atoms. And that relationship works for every single atom in the periodic table. If I take magnesium, it's got a mass number of 24, and what they found out is if they weigh out that mass number in grams, 24 grams, again it will have the same number of atoms. You might be trying to think about the fact that magnesium is twice as heavy as carbon. So if you weigh twice the mass, you'll still end up with the same number of atoms. Rather than keeping it like this 6 times 10 to 23, they thought they're going to give it a catchy name, so they referred to that as the mole instead. So in other words, 12 grams of carbon equals 1 mole of carbon, which just means 6 times 10 to 23 atoms of carbon. It goes up and goes down, so if I had 6 grams of carbon weighed out, that would just be half a mole of carbon. So you can do it by ratios as well. So instead of using ratios, we just use an equation mainly. So you'll find this on page 4 of your notes. The equation we use normally is this. Moles equals the mass, always has to be in grams, you can't use kilograms or anything like that, divided by, it's written here as MR. MR is just another way of saying RFM, or relative mass. So that could be like RFM, it could be, if it's just an element, RAM. Essentially just means the mass from the periodic table, your mass numbers there. So moles equals mass over RFM or MR. So what I suggest you do, unless you've done it already in class, is look through these examples here, trying to convert some things into moles, and then we'll look going the other direction. So again, have a go at them first if you haven't already, then I'll go through them with you now. So first one, 72 grams of magnesium. So again, moles equals mass over RFM is the key equation I'm looking for. In this first example, the mass is 72 grams. The RFM comes from the periodic table for magnesium, mass is 24. So 72 over 24, in the calculator it goes, that's 3 moles. The standard unit for moles is MOL, that's how you normally write it. If I look at B, it's a little bit more complicated. It's got 4 kilograms. You have to know that there's 1,000 grams in a kilogram. So 4 kilograms will be 4,000 grams. Divided by the RFM of CuO, Cu64, oxygen 16, gives you 80. 4,000 divided by 80 gives you 50 moles. Part C, 39 grams of aluminium hydroxide. So the mass is just in grams, so that's easy enough. So 39. Have to work out my RFM of this. 27 for aluminium, 16 plus 1 3 times gives you 78. Add that, or divide those together, and that is 0.5 moles. D is probably the trickiest one. You've got a ton of NaCl. Now a key relationship is 1 ton equals 1,000 kilograms. And if you remember, in a kilogram there's 1,000 grams, so you have to times that 1,000 kilograms by 1,000 again. That gives you actually 1 million grams in a ton. Obviously that's a very big number, but you can still chuck that into your calculator. So the top of my fraction for D will be 1 million. Divide by the RFM of NaCl, that's 23 plus 35.5, gives you 58.5 on the bottom. Divide that together, to the nearest whole number it's 17094 moles of sodium chloride. Final bit, part E, again trickier one, 20 milligrams of copper nitrate. Again, there's 1,000 milligrams in a gram. So to turn that into grams, I need to divide it by 1,000 because that's a very small number of grams. So 20 divided by 1,000 is just 0.02 grams. So that goes on top of my fraction. 0.02, the RFM of copper nitrate, 64 plus 14 plus 16 times 3 twice, gives you 188, which gives you, I'm going to give you standard formula calculator, 1.06 times 10 to the minus 4 moles of that. So that's the standard way of using your mole calculation, going from a mass of something to a number of moles of something. You can obviously go backwards as well, because if you think about the equation, moles equals mass over RFM or MR. If I just do a wee bit of rearranging, if I bring that to the other side, divide becomes multiplied. So that gives me mass equals moles times RFM. So I can go both ways. So there's 5 more questions here. Let's go through now. Turning these moles back into masses. A, moles is 5. RFM of Cl2 is 35.5 twice, which is 71, which gives you 355 grams. B, 0.2 moles. The RFM of Al2O3 ends up being 102, which gives you 20.4 grams. C, you've got 0.01 moles. It's just an element Ag, so it's just the mass number in the periodic table. That mass number is 108, which gives you 1.08 grams. D, 0.002. It's got an ugly looking formula here, but just have to add it up carefully. 14 and 4 for the 4 hydrogens twice. 32 and 16 times 4 gives you 132. Multiply together gives you 0.264 grams. And final part E, 0.3, and again, really hideous looking formula, but remember those bars are just part of that formula. Adding that all together should give you 286, unless I've made a mistake there. And that gives you 85.8 grams. So again, we haven't really gotten to the point about why this is actually useful, but as long as for now you're happy that you can go from a mass and a formula to get number of moles, and a moles with a formula to get back into mass again.